Hello everyone. Let's look at today's Leetcode problem 240 kth smallest product of two sorted arrays. Before starting this problem, let us look at a motivational quote for today. Greatness takes time. Trust the process and keep working towards your long-term goals. Sports athletes are incredible source of motivation because they constantly push the boundaries of human potential, proving that what seems impossible today become reality tomorrow. Similarly, in our uh, problem solving skills also, if we continue to work hard every day, we would also eventually become master at problem solving skill, right? Okay, so let us understand this problem. This is an hard mark problem. So given two sorted zero indexed integer arrays nums1 and nums2 as well as an integer k, return the kth smallest product of nums1 of I and nums2 of j, where I is less than nums1 dot length and j is less than nums2 dot length. So to better understand this problem, let us see if we can get some more information in this example. Suppose there are two arrays nums1 and nums2. We need to find second smallest product. For example, 2 into 3 is equals to 6, 2 into 4 which is equals to 8, 5 into 3 is equals to 15, while 5 into 4 is equals to 20. Out of these, the second smallest value is this one, the first one is this one, the second one is this one, the third one is this one. So we are required to return this value, the k at 2, and that's our output. So understanding this, uh, all of these other examples also mean the same. So the problem itself is very simple, but only thing that makes this problem an hard mark problem is with respect to these constraints, where let's say if we multiply nums1 and nums2, we need to see that this is 5 into 10 power 4 into again 10 power 4. So this will be very high, 25 into 10 power 8. This will give us time limit exceeded. So we somehow need to come up with a solution where time complexity would be log n 1 into m, or the n2, something like this we might need to come, right? So having to find an binary search approach where somehow we can split up our uh, search to the k smallest product with nums1 and nums2 should be our goal. Right. So let us look at an approach on how we can solve this problem. So firstly, it would be better if we sort nums1 and nums2. next step, we are going to have a function which helps us count pairs, which takes in a specific value x, and it gives us this returns count. So here what we are going to do is we are going to iterate for a in nums1, and we check if a is equals to 0, and if x is greater than or equal to 0, then we understand that a into b, b being b is equals to nums of j. Any value b will be 0 and count will be count plus nums2 dot length. So that means a into all of the b elements are less than the product. So that's what we have here, right? If x is less than 0, then since this product a into b is equals to 0, then we do not need to add anything. Count need not be increased, right? So this is the first thing, right? Let me continue. So now we looked at a case where a is equals to 0. Now let's say a is greater than 0. We want to do certain operations where if a is greater than 0, then we want to check if a into nums of j is greater than is less than or equal to x, right? And if this is the case, then this means product is less than x, and we can start adding count value, right? Count can be increased by +1, right? So for this, here what we are doing is we are basically, if a is greater than 0, we are saying that nums2 of j should be less than or equal to x divided by a, right? So if this is the case, then we can increase the count. Similarly, if x is less than 0, or a which is part of the nums1 which is less than 0, then nums2 of j should be greater than or equal to x of a. So this sign reverses, right? And here we perform a binary search where we say left is equals to 0, right is equals to nums2 dot length, and we perform all the operations of count, left less than right, and we check for the mid value, left plus right divided by 2, and if a into nums2 of j is less than or equal to x, then right is equals to mid, right? So if this value is less than j nums2 uh, nums2 of j, a is a into nums2 of j, uh, product is less than x, then we shift the right pointer, or we shift the mid value to the right pointer. We reduce the search by moving the uh, mid value to the right pointer, and then again we iterate through this loop until we find a specific value. Else we say left is equals to mid plus 1 and continue the search as long as we find this condition. So this happens in both a is less than 0 and a is greater than 0, right? So this is our core logic. Uh, After all these, we always increase the count by plus 1. Okay, and the last important part of the function is with respect to performing a binary search. To say count of pairs. Greater than or equal to k is greater than or equal to k, then we should reduce our right value to the mid pointer, and similarly else left value will be moved to the mid pointer plus 1, and finally we can return left pointer. So that's our final thing, right? So first thing is we are going to sort this array. Next is we are going to count the number of pairs, and so in count pairs it returns the count, and we are iterating through the nums1, and for each nums1 we have three different cases. Case 1, where if a is equals to 0 and x, or product x is the product, that is a which is part of nums of I, and let's say into nums of j. If x is greater than 0, then we can say all of the values multiplied with nums of j is equals to is also a valid one, where product will always be 0 and x is greater than 0, so we can increase the count to count plus nums2 dot length. While if x is less than 0, if x is less than 0, then product is equals to 0, and the product is equals to 0, which means all of the product values is greater than x as it is less than 0, right? And there is no need to up the count. So in case of the case 2, so let's say a value a in nums of I is greater than 0, then we need to find all the elements where a into nums of j is less than or equal to x, right? This is as part of a greater than 0. While if a is less than 0, then we need to find all the elements where a into nums of j should be less than or greater than or equal to x by a. This is the derivation that we have come up with. So in here, um, since a is greater than 0 and nums2, assuming that it's a positive value or greater value, we always need to find the product which is less than or equal to x. So our nums2 should be something like this: x by a should be less than a, and if we change the value of x here, so this sign also should be changed. So that's the only thing that is happening here, and we would be using binary search in this format to find the all possible counts in this case and also this case. And finally we are going to find the specific index of k with this binary search, which would lead us to a specific element marked with left. So let us apply this thought process to the code and let's try solving this problem. So we are going to keep both the arrays sorted. That's the first step that we are going to do. Once we have these arrays sorted, we are going to initialize the left and right values. Left value will be 1 into e power 10 to be considered as the maximum, and right will be plus of 1 into e power 10, right? Or we can say simply 1 into e, and we might want to fill in count pairs function, which returns us some count, and we are going to perform binary search to find a specific value where we get the kth smallest product. So we are going to perform binary search here. If count is greater than or equal to k, then we are simply going to increase the right value, or we are going to change the right pointer to the mid value as we consider decreasing the upper bound. else we are going to increase the left pointer to mid plus 1. Okay, so before we proceed any further, let's try completing the count pairs function that we have here, right? So and once we perform the binary search here, we are going to say count all the values which are less than the left index, right? So once we have that, we are also going to do a similar thing where a is less than 0, or we can just say, we can just keep this else part as we have one where a is equals to 0, a is greater than 0, and this would be the last part, clearly understood that a is going to be less than 0, right? And So let's try submitting the solution. Okay, as you can see, the solution gets submitted. If you want to understand the time and space complexity of the solution, time complexity would be of n into log m with the longest reach, right? So it would be n into log m, and space complexity would be of 1. Hope you found this video helpful. Please like and subscribe to my channel. Thank you.